Welcome back. We're going to continue our discussion on aldehydes and ketones. We've looked at how to synthesize and name aldehydes and ketones. Now we are going to use aldehydes and ketones to make other products out of it. Now I have come up with this flow chart. So we're starting with that. All our reactions will have either an aldehyde or a ketone as a reactant. And a simple oxidation will give you acids. Doesn't matter whether it's an aldehyde or ketone. However, ketone does require more aggressive environments to carry out the oxidation, but nevertheless, aldehydes and ketones on oxidation will give you acids. Aldehydes and ketones using simple reduction will give you alcohols. But then there's a whole series of reactions that are under the big umbrella of what is called addition or nucleophilic addition reactions, and here's all of them. Now I am not going to quiz you this flow chart, okay? The flow chart is there as a way to guide you to remember what does what. Say you're sitting down to study for exam 1. If you just look at the flow chart, it will give you a visual idea of everything that you know about the topic. Say if something strikes, oh no, what is that one? Okay, just go to that one and then look at it. So think of this as a way for you to just gather all your thoughts in one single vision, okay? So that's what it's there for, and it also helps me guide to develop content for the videos. That way I'm not just throwing things randomly everywhere. So I try to keep the video time very small because all of these reactions are very simple, and there are a lot of easier ways that I will tell you to remember them, because again, you do not have to remember the reagents themselves. You just have to know how to convert the reactant to the products. You must find some way of remembering certain things. All right, so without further delay, let's do a couple of reactions on this video, and then I'll try to wrap it up pretty quickly because all of these are very, very simple, okay? So this is a simple reduction. So you have an aldehyde and a ketone. I'm going to use the same exact reactants of aldehyde and ketone for all the reactions just to be consistent, because it doesn't matter. At the end of the day, an aldehyde is an aldehyde, a ketone is a ketone. I do not have to create 10 million different reactants to teach this topic. Just these two will be carried out throughout for the most part, so that the content is simple, it's to the point, and makes it easier to follow. Does that make sense? All right, let's keep going. So the first one is an aldehyde. As we know, reduction, a simple reduction is H2 in the presence of platinum, hydrogen. So indication of reduction. Second is also this. All we're essentially doing is rewriting the entire reactant again, except replace the double bond O with an OH. Just like opposite of oxidation. Same thing. This is an aldehyde, because the double bond O is in the end. This is a ketone. So aldehyde would go to a primary alcohol as a product, and ketone would go to a secondary alcohol. I think we did learn this in Chem 330. I believe we did learn it towards the very end. So replace the double bond O with an OH, and that's a simple reduction. What a simple oxidation does, again, the same exact reactant, aldehyde and ketone. You do not have to remember these, okay? Just remember your reagent contains plenty of oxygen, so it's an oxidizing agent, so it does oxidation, okay? So this is an aldehyde. An aldehyde on oxidation. An oxidation in chemistry is usually O. This is not the reagent. This is a shorthand notation for oxidation. Okay, this does not mean that these are replaced by a O. O just means oxidation is carried out. Aldehyde under mild or moderate oxidizing agents will give you acid, and so is ketone. Okay, there's not much difference between How the product is formed is different, but both aldehyde and ketone on oxidation gives you an acid. So what would be, if you throw any of this reagent into this reaction mixture, all you're going to do is write pretty much everything the same for an aldehyde, even including the O, and just add a OH to the carbon that contained the double bond O. That's simple. Whereas with this a ketone, you are going to chop like right here. Oops, sorry. Right where the carbon containing the double bond O is, we're going to produce two acid products, okay? I think typically also when you have a ketone, this is usually the reagent that will be given because this is a little bit more aggressive reagent. So you're going to take the compound containing the double bond O, just break it, add a OH. So that's one other product. And for the other product, okay, you're still going to add a C, a double bond O, and a OH. Does that make sense? So basically to this end, you're going to add a C and a double bond O and a OH. So that's how you complete the product, okay? Basically, you're producing two acid products. To the one side, you just add a OH to the carbon that actually contains a double bond O. And to the other end, the end that broke off, this long chain, you add a C and a double bond O. So basically, you add this to the broken part of it. That's hard to remember, but it's not that hard, really. Okay, so let me do one more as part of the nucleophilic addition because it's easier. Okay, so this is part of the nucleophilic. This is hydride reduction, and the reaction is easy to, again, it's easy to remember because the reagent contains a lot of hydrogen. Very, very simple. All you've got to do is replace the double bond O because it's a reduction. Replace the double bond O with an OH. This is for an aldehyde. Okay, again, an aldehyde on reduction because it's hydrogen and it's also sodium borohydride. Reduction goes to a primary alcohol, and this is a ketone. And again, we do exactly what we did for the hydrogen and platinum because they're both reduction at the end of the day. But this is a different type of reduction, okay? And a ketone goes to a secondary alcohol. Okay, I'm going to stop this here, and then I think it might take 2 more videos to wrap up all of the remaining reactions. So stay tuned for the remaining of the nucleophilic addition reactions. We just done one.